between a client and a server over a network. And so what's going to be happening is that for encrypting the data, TLS certificates are going to be used. And this is what you see when you go onto websites and it says HTTPS. That means that the connection between you and the server is going to be encrypted using TLS certificates. Why do we want encryption in flight? Well, because we're sending data over a network and sometimes a public network, and the data goes around many different servers. We don't want to be having a man in the middle attacks where a middle server receives the data and just observes the packages we're sending to the server. This is why we want to have HTTPS or TLS or SSL. This is when we know that only the target server can decrypt the encrypted data we're sending. So let's take an example. We have a client and a server, and we want to be able to securely log in into the server by providing our username and password. But we only want the target server to be able to receive it. So we're going to have the username and password, and then we're going to apply TLS encryption on the client side automatically. The data is going to be encrypted and sent over the network. So as you can see, no between server can decrypt the data, and only the target server can use the TLS decryption mechanism to decrypt that package and then see that we sent the username and password, and therefore say that we're securely logged in. So that's for encryption in flight. The next one is around server-side encryption at rest. The idea is that the data will be encrypted after being received by the server so that it's stored securely. And the data will be decrypted before being sent back to our clients. It will be stored in an encrypted form thanks to a key, and that key is usually a data key. And so the whole idea of managing these keys for encryption and decryption is that the management must happen somewhere and the server must have access to these keys. So let's take a service, for example, Amazon S3. We're sending an object over HTTP, maybe even HTTPS for encryption. And so the service receives our object, but it is decrypted. So the service can use a data key, and using the data key and the decrypted objects, we can have encryption of that object at rest. And then when it comes to sending back that object to the client, the encrypted object and the data key will be used together to decrypt. We'll have a decrypted form of object, and then that object will be sent over HTTPS back to the client, so we receive the decrypted object as is. As we can see in this case, there is a server-side encryption because all the encryption and decryption happens on the server. So finally, let's talk about client-side encryption. And the idea is that this time, the data is encrypted and decrypted at the client side. And the server should never be able to decrypt the data because we don't trust the server in that case. So for this, we could leverage envelope encryption for this mechanism. So let's have an example. The client has an object, and the data key this time is client-side. And after encryption, we get an encrypted object. That encrypted object can be sent then securely to any sort of service, for example, an FTP server, Amazon S3, EBS volume, etc. And it will be stored in encrypted form. So the target server cannot even decrypt the data content. When we retrieve the content, we retrieve the encrypted object directly. And if we still have access to the data key client side, then we're able to perform the decryption mechanism and get the decrypted object back. So that's it for the 3 encryption mechanisms we can see in the cloud. I hope you liked it, and I will see you in the next lecture. So now let's talk about AWS KMS, which is the key management service of AWS. So we've been using it, a lot without knowing, but anytime you hear encryption when you have an AWS service, it's most likely going to be KMS encryption. The idea is that with this KMS service, AWS is going to manage the encryption keys for us. And that's great because that means that we have less things to do. So KMS is, of course, fully integrated with IAM for authorization, and it gives us very easy ways to control access to our data if it's encrypted with KMS. The power of using AWS KMS is that you're able to audit every single API call made to use your keys through CloudTrail, which is something the exam may test you on. So on top of it, KMS can be used seamlessly into most AWS services. So for example, if you wanted to encrypt the data at rest in an EBS volume, just enable the KMS integration. Same for S3, same for RDS, same for SSM, and same for pretty much all the services that require encryption. The idea is that with KMS, you can also use it yourself. And if you have secrets data, you never ever store them in plain text. That means just as is, especially in your code. So if you want to use KMS, you can also use KMS through API calls. You can use the AWS CLI or the SDK. And that means that you can encrypt whatever is a secret for you with a KMS key. And then these encrypted secrets can be, for example, stored in your code or in environment variables. That is a much better pattern. So now let's talk about the different types of KMS keys available to you. So now it's called a KMS key, by the way. It used to be called the KMS customer master key, but it was confusing because there's also the customer managed keys, as we'll see in a second. So now we just talk about KMS keys. So we have 2 types of KMS keys. We have the symmetric KMS keys, and that means there's only one single encryption key that is used to encrypt and decrypt data. And so any service of AWS that is integrated with KMS will use symmetric keys. The idea is that when we create or use a KMS symmetric key, then we never get access to the key itself, okay? All we do is that we use the KMS API calls to leverage and use that key. The second kind of key available on KMS are called asymmetric keys. That means that you have 2 keys. You have a public key, that's used to encrypt data, and a private key used to decrypt data. So this is used when you have encrypt, decrypt, or sign verify type of operations. And in that case, you can download the public key out of KMS, but you cannot access the private key. You can only use API calls against to access the private key. So the use cases for an asymmetric type of key is when you want the encryption to be done outside of your AWS cloud by users who cannot or don't have access to the KMS API key, in which case they will use the public key to encrypt the data, send it over to you, and you within your account, you would use the private key of AWS to decrypt that data. So within the world of KMS keys, you have different types of KMS keys. The first one are AWS-owned keys. They're free, and this is the kind of key you would use when you use SSC S3 type of encryption or SSC DynamoDB, where you have the option, for example, that to choose a key owned by DynamoDB. So these are not really KMS because you don't really see them, but they're types of encryption keys within AWS. Then you have the AWS managed keys, and they're free, and you will recognize them because they start with AWS/ and then the service name. For example, AWS/RES or AWS/EBS, or in this example, AWS/DynamoDB. They're free, and you can just use them as you please, but only from within the service that it's assigned to. Then you have your own customer managed keys, and they're custom keys, and they cost you $1 per month. And if you want to import them as well, you can import them, and they cost you $1 per month. KMS also has a pricing where you're going to pay for each API call made to the KMS service, which is about 3 cents per 10,000 API calls. You also have automatic key rotation. So if it's an AWS managed KMS key, then it's automatic every 1 year. And if it's a customer managed key, you can enable automatic rotation and you set the period. And you can also have on-demand rotation of your key. And if it's imported KMS key, then you can only manually rotate it. And for this, you need to leverage an alias. So KMS keys are scoped per region. That means that if you have an EBS volume encrypted with KMS key in a region, for example, EU West 2, then if we want to copy that to a different region, we have to do several steps. First of all, we have to take a snapshot of this EBS volume. And if we take a snapshot of an encrypted snapshot, then this snapshot itself will also be encrypted with the same KMS key. Then, to copy the snapshot to another region, we need to re-encrypt the snapshot using a different KMS key. And this is something AWS will do for you. But the same KMS key, but cannot live in two regions. So now we have an EBS snapshot, it's encrypted with KMS, with a different key, and it lives in another region. Now we restore the snapshot into its own EBS volume with KMS, and its KMS key B into the region AP Southeast 2. Now the other thing you need to know about is KMS key policies. So this is to control access to your KMS keys. It's similar to an S3 bucket policy, with the difference is that if you don't have the KMS key policy on your KMS key, then no one can access it. So in that regards, we have two types of KMS key policies. We have the default one, and it's created if you don't provide a specific custom KMS key policy. And the idea is that the default allows everyone in your account to access this key. That means that if you have an IAM policy allowing a user or role to access this key policy, you're good. But if you want to have more specific controls over it, you could use a KMS key policy that is custom, in which you define the users, the roles that can access your KMS key. You define who can administer the key, and this is especially helpful if you want to do cross-account access for your KMS key, because we can authorize another account to use our KMS key. So when do we use this? Well, for example, if we wanted to copy an encrypted snapshot across accounts. So we create a snapshot encrypted with our own KMS key, and it's a customer managed key. It must be that because we need to attach a custom key policy. And then we attach a KMS key policy to authorize for cross-account access. It looks like this. Then we share the encrypted snapshot with the target account. And then in the target account, we create a copy of the snapshot and we encrypt it with a different customer managed key in that target account. And then we can create a volume from the snapshot in the target account, and we're done. So that's a lot of information about KMS, but let's go into hands-on to hopefully learn a bit more about it. So let's have a look at the KMS service. And first on the left side, I want to look at the AWS managed keys. You can see if I've been using KMS encryption throughout this course, then these keys will appear right here. So we can look, for example, at the AWS EBS, and this is an AWS managed key because it belongs to the EBS service. So we can have a look here how it's being used. So there's a key policy, and this policy defines what can access this key. And of course, because this is an EBS AWS key, then you will look at all the actions. So it can come from anywhere, do some kind of actions, but the condition is that the color account has to be mine, and the VIA service has to be the EC2 service, which is a service above the EBS service, okay? If I looked, for example, at another AWS managed key, for example, the SQS one, and look at the key policy, here, the VIA service, as a condition to my KMS key policy, is the SQS service, therefore allowing only access from SQS to this key. We can also look at the cryptographic configuration, which shows that this key is symmetric of origin KMS, and it's used to encrypt and decrypt data. Okay, so that's for the KMS managed key by AWS, but then we have other kinds. We have the customer managed keys, as well as the custom key store. So the custom key store is when we want to use Cloud HSM, but this is out of scope for this exam. So we don't go over this, we're just going to go over the customer managed key. So this is when we want to create our own keys within KMS and not use the ones managed by AWS. So let's create a key, but if we do so, remember, this is going to cost you $1 per month. So if you don't want to pay anything, then do not do this. So here for the key type, I have multiple options. I have the symmetric or asymmetric type of key. So if I use asymmetric, this could be used for encrypt and decrypt or sign and verify type of operations. But this is out of scope for this lecture. I'm going to use the symmetric type of KMS key, and we'll use the encrypt and decrypt option. Okay, this is the most basic one I want to show you. For advanced options, the key origin is going to be KMS because we want KMS to create this key for us. If we wanted to import a key, this would be the external type of key origin, or custom key store if you wanted to have Cloud HSM, but again, this is out of scope. So we'll use KMS, and here for regionality, we have single region key and multi-region key, and we're just going to consider single region key right now because this is the oldest type of option and the most common for KMS. So we'll use single region key, click on next. Next, we have a key alias, so I'll just have it as tutorial. Click on next. And here we can start defining key administrators. So if I don't define one, then we're going to use the default KMS key policy, which is what I want. But if you wanted to be very specific about who can use this key and who can administer it, this is where it would happen. So right now, I'm not going to tick anything and click on next. Then you can say who can use this key. So again, this is for your KMS key policy. To be more specific, right now I want to allow everyone to use it if they have the right IAM permissions. But if you wanted to also have some extra security, you could say, hey, only Stefan can use this key. And this would create a custom KMS key policy. But in this instance, I don't want this. And as you can see at the bottom, I can choose other AWS accounts to access my key. So this is if you had, for example, the use case of sharing an encrypted snapshot, an EBS snapshot, for example, you would add another account to allow access to your key. So we summarize everything. So we have a symmetric key, and then this is the key policy, and this is what I call the default key policy. This is just to enable IAM user permission. So it allows anything to do any resource on KMS as long as they will have, of course, IAM permissions to do so. So let's finish this. And now my key has been created, and we can click on View Key. So now that my key is created, I can have a look at the key policy. And so the key policy is just like this. It's an IAM policy for your key. But you can switch to the default view, and you can see in a better summary, like who are the key administrators, is it allowed for key deletion, who are the key users, and can other accounts access it. So I won't touch this. Then you can have a look at the cryptographic configuration. I won't touch this. Tags not needed. So for key rotation, we can enable automatic key rotation by editing here and saying yes, it's enabled. And we can set up the rotation period from 90 days to many more days to 2,560 days. So here this is 1 year, but you have the option to customize it. If you enable this, then you know the next rotation date. And also, for example, you can initiate on-demand key rotation by just clicking on this button. Whenever you rotate your key automatically or on demand, it's going to appear in the key rotation history. So these options are available because we have created their key directly from KMS. And finally, what is the alias for my key? It is named tutorial, so I can refer to it with an alias ARN, which is going to be a little bit simpler for us. Finally, for key actions, you can disable it or schedule key deletion. So we have our key, it's great, but now let's go use the CLI to encrypt and decrypt some data. So under KMS, I have KMS demo CLI.sh, which is going to show us how to use the encrypt and decrypt call of KMS with an example. So first we are going to have to create a file. I'm going to call it example secret file.txt, and with it I'm going to say there is a super secret password. Okay, so this is whatever you want in this text file. For me, I just entered a password called super secret password, and we're going to encrypt it and then decrypt it using KMS. So the first thing you have to do for KMS encryption is use the encrypt command. So we have to specify a key ID. For me, it's alias/tutorial. So this corresponds to the key I have created in my console. And you could use the alias. You could use this key ID right here, or you could use the full ARN. It doesn't really matter. Just use whatever you want. And then you need to pass in plain text the address of your file. So for me, it's example secret file.txt. The output of the query. So you're querying for the cipher text block, which represents the encrypted content, and you want the text as is. And finally, the region your key is in. So for me, -region EU West 2. This is going to give us a base64 file containing the encrypted content. So let's copy this command right here and paste it, run it. And now I have a file called example secret file encrypted.base64, and this represents my encrypted file, okay, in base64, so just with letters and numbers that we can recognize. Now, though, we're going to do a base64 decode to get the binary encrypted value. So if you're on Windows, the command is different. So for Linux, I'm just going to run this one, but for Windows, you can run the other one. And so the idea is that you're going to create a file called example secret file encrypted without a base 64. So let me copy this and paste it. And now I have a new file called example secret file encrypted. And if I try to open it with my text editor, it's not going to work because it uses either binary or unsupported text encoding. So this is indeed a binary file. So this is the kind of secret file that you would share with someone. And so now I want to go and decrypt it. So this is completely gibberish and we cannot get any information out of it. Even this one, we cannot get any information. How do we know it's super secret password? So this is an encrypted file. But now we want to take this encrypted binary file and decrypt it. So for this, we're going to run an KMS decrypt command. So this time we pass in the block, the file that was encrypted. So this is where we pass in the file in here. Then we query for the plaintext value, so the decrypted value. And we write this to another file that is going to be base 64 encrypted. And we specify the region. So let's go ahead. KMS knows automatically which key to use for the description because it is included in the blob of encrypted value. So let me enter this, and so this has succeeded. So now if I go to my example file, decrypted base 64, it is here. It's a much shorter thing, and now we're going to base 64 decode this to get my text value. So we'll have a different command again if you're on Windows or if you're on Mac. So I'm on Mac, so I'm going to use this one. So I'm copying this command, pasting it, and now we have done a base 64 decoding of our file. So if we go back to example file decrypted.txt, we find back our super secret password. So we have shown the encryption and its reverse operation, the decryption. Obviously, these are low-level commands. The SDK will abstract some of that for us, but this shows you the full example of how you can use the encrypt and decrypt command of KMS with your own customer master key. So that's it, super simple. I hope that was helpful, and I will see you in the next lecture. So now let's talk about KMS multi-region keys. So we have KMS and we can actually have a multi-region key. That means that you're going to have your primary key in one selected region, such as for example, US East 1, and then that key is going to be replicated to other regions, for example, US West 2, EU West 1, and AP Southeast 2. And so the similarity is that the key material is going to be replicated. The same key is going to be in other regions, and the key ID is going to be the exact same. So as you can see, the key ID / MRK and then whatever is the same across all regions. And this is the principle behind the KMS multi-region keys. So why would you use them? Well, it's a set of KMS keys that you can use in different AWS regions, and they can be used interchangeably. So that means that you can encrypt in one region and then decrypt in another region. And multi-region keys, they're possible because they have the same key ID, the same key material, and if you have automatic rotation enabled for the primary key and it actually rotates, it's going to be also replicated to the other regions. So the idea with that, with a multi-region key, you can encrypt in one region and decrypt in another region. And you don't need, therefore, to re-encrypt your data when moving from one region to the next, or to make cross-region API calls. So something to understand, though, is that KMS multi-region keys are not global. Okay, you have your primary and your replicas, and each multi-region key is going to be managed independently with its own key policy and so on. So it's not recommended to use multi-region key except in very specific use cases because KMS likes to have the fact that the key is bounded to a single region. And so the use cases for using multi-region keys is if you want to have a global client-side encryption, so to be able to encrypt client-side in one region and to decrypt client-side in another region, or to do encryption on global DynamoDB tables or on global Aurora. And we'll see this in a second. So how does it work when you use global tables in DynamoDB and KMS multi-region key with client-side encryption? So the idea is that you want to encrypt not just the whole table, because this is just at-rest encryption. You want to encrypt actual attributes on your table, and so that they're only available to specific clients. Not even to database administrators. For this, we're going to use the Amazon DynamoDB encryption client. So let's take an example where we have US East 1 and AP Southeast 2. So the KMS service is having a multi-region key, which is replicated to another region, the region AP Southeast 2. And the client application wants to insert data into a DynamoDB table. So first, it's going to encrypt the attribute that it needs to be encrypted with the primary multi-region key. So the idea is that the DynamoDB table, most of the fields will not be encrypted, client side, okay? But then one of them, for example, the social security number, is going to be encrypted. So this is great because, well, your database administrators that have access to your DynamoDB table, if they don't have access to the KMS key that was used to encrypt that one attribute, the social security number, then they will not be able to access it. So it gives you a protection even against the database administrators. So if this DynamoDB table happens to be a global table, then this data is going to be replicated to another region. And so this is now in AP Southeast 2. And thankfully, we've decided to encrypt our data, the attributes, with a multi-region key. And therefore, a client application in the AP Southeast 2 region can retrieve the row, see that one attribute is encrypted, and then perform an API call to actually decrypt the attribute with the replica multi-region key. And this is why we are doing multi-region key instance. Is it so that client applications in the AP Southeast 2 can do a local API call to KMS to decrypt that one attribute. So using this client-side encryption technique, we can protect specific fields or attributes on our data and only guarantee decryption when our client has access to an API key. And thanks to global tables, we can make sure the data and the encryption keys are also replicated together. So the same concept can be applied to global Aurora, so I will go a bit faster. And this time we're going to use the AWS encryption SDK. So we have two regions and we have a multi-region key in KMS replicated across these two regions. And so the client application wants to encrypt a column. Yet again, it is my SSN column. And this time we put the data into an Amazon Aurora database with a table. And so all the data is unencrypted on this one row, except that one column, which is the SSN, which is encrypted actually with the MRK, the multi-region key. Now, this is a global database. So that means that the tables are going to be replicated globally. And therefore, the same data is going to happen to be in the AP Southeast 2. And because we have clients in the AP Southeast 2, they're going to get this encrypted data from your table. And because we are using a multi-region key, they can do a local API call to KMS to decrypt this attribute. And therefore, we have achieved lower latency. So we've seen that using client-side encryption, we can also protect this data even from database administrators. So if you have a database admin that accesses your Amazon Aurora database and wants to access that one column, the social security number, unless they have access to the KMS key, they will not be able to read this data, which is very helpful. So that's it for KMS multi-region keys. I hope you liked it, and I will see you in the next lecture. So now let's talk about S3 replication and its relation to encrypted objects. So if you enable S3 replication from one bucket to another, then any unencrypted object and objects encrypted with SSC S3 will be replicated by default. Objects that are also encrypted with SSC C, with the customer provided key, can also be replicated. And then we have objects encrypted with SSC KMS. So by default, they're not replicated, but we need to enable the option to actually replicate these objects. And so we specify with which KMS key we want to encrypt the objects within the target bucket. And then we adapt this KMS key policy for the target key. And we create an IAM role that is allowing the S3 replication service to first decrypt the data in the source bucket and then re-encrypt the data in the target bucket with the target KMS key. And so when you do so, this enables replication because there's a lot of encryption and decryption happening. You may get KMS throttling errors, in which case you need to ask for a service quota. So a question you may have is, should I use multi-region key with S3 replication? And the documentation says that you can use multi-region key for S3 replication, but currently they are treated as independent keys by the Amazon S3 service, and therefore the object is still going to be decrypted and then encrypted using the same key, even though the key is a multi-region key. Okay, so this is it for this lecture. I hope you liked it, and I will see you in the next lecture. So here is a question that can come up in the exam. This is around the process to share an AMI with another account and the AMI has been encrypted with a KMS key. So the AMI is in your source account and it's encrypted with your KMS key. So how do you launch an EC2 instance in account B from the AMI in account A? So first you must modify the AMI property with a launch permission, and this launch permission allows account B to launch this AMI. So effectively, this is how you share an AMI. You must modify the launch permissions and add the specified target ADOS account ID. Then you need to also share the KMS key for the account B to be able to use it. So this is done usually with a key policy. Then in account B, you would create an IAM role or IAM user with enough permissions to actually use both the KMS key and the AMI. So you must have on the KMS side access to the describe key API call, the re-encrypted API call, create grant, and decrypt API calls. And then once all of this is done, you can simply launch an EC2 instance from that AMI, and optionally the target account can choose to re-encrypt everything with the KMS key that it owns in its own account to re-encrypt the volumes. But there you go, you can launch an EC2 instance. And so if you understand this process, you're good to go to maybe answer one question at the exam. I hope you liked it, and I will see you in the next lecture. So now let's talk about the SSM parameter store. It's a secure storage for your configuration and your secrets. And optionally, you can choose to encrypt these configurations and therefore make it secret by using the KMS service. SSM parameter store is serverless, it's scalable, it's durable, and the SDK is very easy to use. On top of it, if you update your parameters, then you have version tracking of them. The security is provided through IAM, and you get notifications with Amazon Event Bridge in certain amount of cases. You have full integration with CloudFormation. That means that CloudFormation can leverage the parameters from Parameter Store as input parameters for your stacks. So let's take an example. We have an application, and then we have the SSM parameter store. So we can store plain text configuration. In this way, then the IAM permissions of your applications are going to be checked. For example, your EC2 instance role, or you can have encrypted configuration. In that case, the SSM parameter store is going to encrypt it with KMS, and so the KMS service is going to be used for encryption and decryption. And of course, you need to make sure that your application do have access to the underlying KMS key to perform that encryption and that decryption. So you can store parameters in the parameter store with a hierarchy. So for example, you can define my department as a path, and underneath the my app, and then the dev, and then we have the dev DB URL, and then the DB password within that folder. So that means that your parameters goes all the way down into the hierarchy. We can go one level up and store a parameter for the prod DB URL as well as a prod DB password, and go up to another app or another department. That really allows you to organize your parameters the way you want in a structured fashion, and then this is going to simplify your IAM policies to allow applications to have access to an entire department or to an entire app or just to an app department environment specific path. You also have the opportunity to access secrets of Secrets Manager through the parameter store by using this reference right here. So it's a little trick that not many people know. And there are something called public parameters that are issued by AWS that you can use. For example, if you want to find the latest AMI for the Amazon Linux 2 in your specific region, this is something that's available within the parameter store as an API call. So if you take an application, for example, our dev lambda function is going to have an IAM role that allows it to access the DB URL and DB password within the dev of my app. And then if you have a prod lambda function, thanks to, again, the different IAM policy and maybe some environment variables, you can access the prod DB URL and prod DB password of another path. Now within Systems Manager, you have two kinds of parameter tiers. You have the standard and the advanced tier. So the big difference is going to be around the size, so 4 kilobytes versus 8 kilobytes, and also the availability of a parameter policy. For standard one, we have none, but for advanced, we have some. The advanced type of parameters is going to be $0.05 per month, whereas the first one is going to be free. So what are these parameter policies? And this is only for advanced parameters. Well, this allows you to assign a time to live to a parameter, that means an expiration date, so that you force users to update or delete sensitive data such as passwords. And you can assign multiple policies at a time. So here is an example policy. So this is an expiration policy to delete a parameter, and you say, hey, on this timestamp, you must delete this parameter. And then through the Event Bridge integration, Event Bridge is going to get notifications of it. So in this example, 15 days before the parameter expires, we'll receive a notification in Event Bridge, which gives us enough time to actually update it and make sure the parameter is not getting deleted because of the TTL. Or maybe sometimes you want to make sure the parameters change once in a while. So you can have a no change notification in Event Bridge so that if a parameter has not been updated for 20 days, then you will be notified as well. So you can get very creative with the parameter store, but now you get the idea behind it. So I hope you like this lecture, and I will see you in the next lecture. Okay, so let's go ahead and practice using the parameter store. So the best way to do it is to type parameter store in the search bar, and you can click here. It's a Systems Manager feature. So if you click on parameter store, on the left-hand side, you will see that under Systems Manager, you have under Application Tools, the parameter store. And what we can do here is create a new parameter, we specify types and values, and then we can reference the parameters in the commands or the code. So let's go ahead and practice using this service. So I first create a parameter, and I need to enter a name for it. So the name is whatever you want. You don't have to follow my direction, but I like to name it like this. So /myapp/dev/db_url. And this is going to allow me, with these 4 slashes, to organize them into a hierarchy. So this is my app, this is the dev environment, and this is the name of my parameter within the dev environment. So here I said db_url for the dev environment. That's perfect. And then tier, we have 2 options. We have standard and advanced. So we're going to use the standard tier. We can store up to 10,000 standard parameters. They are 4 kilobytes in value maximum, and we can't share them with other accounts. But the advanced parameters, you can have 100,000 of them. They can be 8 kilobytes, and you can share them with other accounts. So next, we're going to choose the type. And the type could be string, string list, or secure string. So here, we're going to use string, but later we'll be using secure string. And if you need a list of string, you can have a string list. But string here has data type. It's either text or AWS EC2 image, because you can also reference image ARNs here. And here you just have to specify the text in a specific format. But we'll use text. And for the string, I will have, for example, dev.database.stefan.teacher.com. This is just an example. You don't have to put anything that's a URL. You can put whatever you want in it. But that's going to be the value of my parameter, this one. So let's create this parameter. And as you can see now, it's been created. I can click on it and have a look at it. So this is version 1 of this parameter. We can view the version history here. So if I were to change it, then I can, of course, update it, but I will have access to my version history, which is nice. And then we're going to do the same, but add more parameters. So we're going to go on the parameter store, and I'm going to copy this. And here I'm going to have it as db password. So we're going to create it. So db password for dev. And as you guessed it, we're going to have a secure string this time. And because it's a password, we're going to encrypt it with a KMS key. So it could belong in my account or another account. We'll use my account. You could use the default KMS key ID managed by AWS for the SSM service, which is this one, alias AWS SSM. Or you can select one that you have created before. For example, you may have created, for example, a KMS, a key, called tutorial, or whatever you want to create it. You don't have to. And so if you had created it, then you can use it here and leverage it. It's really as you want. But let's choose tutorial for this example. It doesn't really matter. And we need to put a password. So I'll have it as dev password. And now this is going to be automatically encrypted by KMS. So let's create this parameter. As you can see now, the type is a secure string. And if I click on it, as you can see, the value is encrypted and hidden. And if I click on show decrypted value, it will check that I have the KMS permission to use the key and then therefore decrypt the value for me. So that's great. What we can do now is just really quickly create the other parameters for prod. So instead of here, I have prod, and I'll call it prod. Let's take on it. Teacher.com 3306. And then for the password, same. I'm going to copy this real quick and have it as prod. We'll use a secure string. We'll use the tutorial one, and then we'll have it as prod password. Okay. So now we have 4 parameters, and they're all available within the parameter store, and they're ordered by a hierarchy. So now let's try to access these parameters using the CLI. So I'm going to open a Cloud Shell on the top, because it has the CLI installed of AWS, and it's already configured. And so what we're going to use is a command called the SSM get parameters. So we'll do AWS SSM get parameters, and then you have to provide names. And the names correspond to the names of your parameters. So I can have, for example, my dev db URL, as well as my dev password, db password. So we'll press enter. And as you can see now, I get a result with my 2 parameters. So we have this one and that one. And you can see that for the db URL, it's a string. The value has been returned as is. But for the db password, it's a secure string and it has been returned as an encrypted value. So to decrypt this value, I'll press enter, 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 and quit, Q. I have to specify a flag. And the flag is called with decryption. And so it's going to check additionally if I have the KMS security policy allowed on my account to decrypt that parameter. So as you can see now, the db password is still a secure string, but now we have dev password as a decrypted value thanks to this flag with decryption. So the CLI is very powerful and something you can definitely use in your scripts. Another command I would like to show you is going to be the get parameters by path. So you do AWS SSM get parameters by path, and then you have to specify a path, and the path is whatever you want. So because we have a hierarchy, we have my app/dev is going to give me all the parameters in this namespace. And as you can see, we get again the dev db password and the dev db URL. But you can do something more now. You can do, for example, my app as a whole, And as you can see, I get nothing. But if I use the flag, and it's a flag called recursion, so it's going to be recursive, then you have access to all the parameters recursively under that namespace. So we have access to the dev as well as the prod type of parameters, which is very neat. So now we have our 4 parameters. And finally, if you want it, of course, you can also use with decryption to decrypt all of them. And that's it. So we've seen how the parameter store is working. We've seen about the hierarchy. We've seen the CLI. And it starts to show you the power of using the parameter store. So I hope you liked it. And I will see you in the next lecture. So now let's talk about a very simple service called the AWS Secrets Manager. So it's a newer service and it's meant for storing secrets, and it's going to be different from the SSM parameter store because on Secrets Manager, you have the capability to force the rotation of secrets every X number of days, and therefore you have a better secrets management schedule. On top of it, from within Secrets Manager, you can force and automate the generation of secrets on the rotation. And for this, you have to define a Lambda function that will generate that new secrets. Moreover, Secrets Manager is really well integrated with different services on AWS. And I just showed you Amazon RDS, for example, for MySQL, PostgreSQL, or Aurora. But there are other services as well within AWS, other databases that are integrated with Secrets Manager out of the box. That means that the username and the password to get into your database is stored directly in Secrets Manager, and it can be rotated, and so on. Now, the secrets can be encrypted using the KMS service. And so anytime in the exam you see secrets or integration for RDS or for Aurora of secrets, really think Secrets Manager. There's one more feature you need to know about, which is the concept of multi-region secrets. So the idea is that you can replicate your secrets across multiple AWS regions, and Secrets Manager service will keep read replicas in sync with the primary secret. So here I have 2 regions. We create a secret in the primary one, and it gets replicated as the same secret into a secondary region. Now, why would we do this? Well, multiple things. Number one, in case there is a problem with USP1, you're able, for example, to promote a replica secret as a standalone secret. And then thanks to the fact that that secret is replicated across regions, then you can build multiple regions apps. You can also have disaster recovery strategies, or if you have an RDS database that is also being replicated from one region to the next, then you can use the same secret to access the RDS database, the corresponding one in the corresponding region. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. So now let's talk about the Secrets Manager service. So as you can see, it's to easily rotate, manage, and retrieve secrets throughout their lifecycle. So it's similar to the SSM parameter store because you can store secret things, but it's going to be different from it because, well, you have rotation, management, and tight integrations with databases such as MySQL, PostgreSQL, Amazon Aurora on RDS, and so on. So the pricing is you have a 30-day free trial available, and then you're going to pay 40 cents per secret per month, and then 5 cents per 10,000 API calls. So if you again expect to remain within the free tier, just create a secret and then delete it. So let's go ahead and store a new secret, and we can choose a secret type. Now over time, it's very possible that this gets increased in terms of the capability of integrations, but we have Amazon RDS, we have Amazon DocumentDB, Amazon Redshift, other databases, or other type of secrets. So if you are on Amazon RDS, as you can see, it prompts you for username and password and so on. And if you go, for example, for other type of secrets, here we can store anything we want. So for example, I can say my secret key, and then my very secret value. And this would be a secret stored in here. And another one could be, for example, API key, and there would be also as well like a secret API key, so you would enter some text in here. So you can enter it through this UI, or you can go in plain text, and you have a JSON document that you can edit it to edit the key values. This is just a different way of specifying your secrets. So this will be kept secret so that only person with the correct IAM permissions can access these secrets. Then we specify an encryption key. So we have the default one, but you can use your own KMS key if you wanted to. I click on next. Then we need to name our secret. So prod my secret, for example, and a description, but I don't need it. Resource permission. So do we want to have a policy that restricts who can access the secret? And it should be across AWS accounts thanks to this resource policy right here, and you would have it in JSON form, so it's similar to an S3 bucket policy. And then you have the option to replicate the secret across regions. And this is good if you want to have multi-region setups, such as multi-region apps or multi-region databases. And here we can say, okay, I want to replicate this into US West 2 using this encryption key right here, and also into AP Southeast 1, and so on. So I'm not going to do this, but this would be how you would replicate your secrets. So then I click on next. Then do we want to automatically rotate our secrets? Yes or no? And when do we want to rotate it? And if we do enable rotation, then we need to specify a rotation function. This is a Lambda function that will be performing this rotation. So for now, disable it. And then we have a look. So we have a secret right here. It's replicated into US West 2. And here's some code if we wanted to invoke and get that secret from our clients. So I'm not going to go ahead with creating this, but as you can see, this would store a secret and then use this code to retrieve within your code the correct secret. So we'll cancel this. Another kind of secret you can have is a credential for an Amazon RDS database. So you would create a username and a password, and then you would specify a database. And the cool thing about it is that thanks to the integration between RDS and Secrets Manager, then this username and this password would be used to be able to log in into the database. And if you wanted to rotate it, then automatically the database also gets updated. So here you would enter it, then you would configure the secrets as well if you wanted to have, for example, some kind of multi-region replication. Rotation as well if you wanted to. Review it, and you're done. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. So now let's talk about the AWS Certificate Manager Service, also called ACM. So with ACM, you can easily provision, manage, and deploy TLS certificates on AWS. What are TLS certificates used for? And I sometimes say SSL. So they used to provide in-flight encryptions for websites. You know, when you go to websites and it says HTTPS, the S stands for secure, and therefore this is where you know that there is a TLS certificate involved in the transaction. So how does that work? Well, you have an ALB, for example, connected to your auto-scaling group, but you want to expose your application load balancer as an HTTPS endpoint. Therefore, you would integrate it with the certificate manager to provision and maintain TLS certificates directly on your application load balancer, and your users will access your website or your API using the HTTPS protocol. So ACM supports both public and private TLS certificates, and it's free of charge if you want to use public TLS certificates. There is also a feature to automatically renew these certificates. We will see this in a second on other slides. And you have integrations with many AWS services, so you can load TLS certificates on Elastic Load Balancers, for example, the classic one, the Application Load Balancer, or the Network Load Balancer, CloudFront distributions, or any APIs on the API gateway. So what's the process to request a public certificate? First of all, you need to list the domain names that are going to be included in your certificates. So that could be a fully qualified domain name, FQDN, such as corp.example.com, or it could be a wildcard domain, for example, star.example.com. And you can include as many domains as you want. Then you select the validation method. Would it be through DNS validation or through email validation? And for automation purposes, when it comes to automatically renewing your SSL certificates, DNS validation is going to be a preferred method. And for email validation, what's going to happen is that ACM is going to send emails to contact addresses in the registrar for your domain and verify that you did request that certificate. And if you decide to do DNS validation, then you will have to create a CNAME record in your DNS configuration to verify that you own the domain. And so if you have root 53, for example, then it's automatically integrated with ACM to do this for you. Next, you have to wait a few hours to get verified, and then your certificate will be issued, and these public certificates will also be enrolled for automatic renewal. That means that automatically ACM will renew any ACM-generated certificates 60 days before expiry, which gives you a lot of peace of mind. So when it comes to ACM, what if you import a public certificate? So you have the option to actually generate a certificate outside of ACM and then import it into ACM, but in that case, because it's been generated outside of ACM, there is no automatic renewal. And so therefore, before your existing certificate expires, you need to import a new one. And how do you know when a certificate is going to expire? Well, the ACM service is going to send daily expiration events starting 45 days prior to expiration into your event bridge service. And the number of days can be configured. You can set 45, you can set 30, whatever you want. So that means that daily you will have an event in event bridge for expiring certificates. And that's one way of doing it. And then from event bridge, then you can trigger Lambda functions or SNS topics or SQS queues. There's another way to use AWS config. And there's a managed rule in config called the ACM certificate expiration check. And it's going to check for expiring certificates. You can configure the number of days again. And so the config service is going to have a rule that will check the ACM service. And then if any certificate is deemed not compliant, then the event of non-compliance will be sent to Event Bridge. And yet again, we can trigger Lambda, SNS, or SQS. So two ways of getting these automatic alerts. Now, how does the ACM service integrate with the ALB? So we've seen we can have an ALB with an auto-scaling group in the backend, and we can provision and maintain a TLS certificate through the ACM service. But there is a very good specificity. On your ALB, you can set a redirect rule from HTTP to HTTPS. That means that if your user is accessing your application load balancer on the HTTP protocol, the ALB will return with a redirect and say, you need to redirect to HTTPS. So the user comes back to the application load balancer, now on the HTTPS protocol, and therefore it will leverage the TLS certificates coming from the certificates manager. And then once a request is going through the HTTPS protocol, then it will be directed into your auto-scaling group. So let's look at how ACM integrates with the API gateway, but first we have to remember the endpoint types. So we have the edge optimized endpoint type for API gateway. This is when your clients are global and the requests are going to be routed first through CloudFront edge locations to improve the latency and then sent to an API gateway that still lives in only one region. You can also have the regional type of endpoint, in which clients are within the same region as your API gateway. In this case, we don't have CloudFront available, but we could still, if we wanted to, create our own CloudFront distribution to have more control over the caching and the distribution strategy. And then we have the private API gateway endpoints that can only be accessed from within our VPC using an interface VPC endpoint. And we need to use a resource policy to define access to this API gateway in a private mode. So ACM makes sense for edge optimized and regional endpoints. So let's have a look at that. So to integrate ACM with the API gateway, first we need to create a resource in the API gateway called a custom domain name, and then we need to configure it. So for edge optimized endpoints, then because the requests are routed through CloudFront, then the TLS certificates are going to be attached to your CloudFront distribution, and therefore the TLS certificate must be created in the same region as CloudFront, which is US East 1. So therefore, your API gateway lives in one region, but then everything is distributed through CloudFront, and your ACM certificates must live in the US East 1 region because this is where CloudFront is located. All the certificates for CloudFront are in US East 1. So then we set up a CNAME or an alias record in Route 53 to be done. And the regional endpoints, okay, they're for clients in the same region as your API gateway. And therefore, because we only have an API gateway, then the TLS certificate must be imported on the API gateway in the same region as the API stage. And therefore, in this example, my ACM is only in AP Southeast 2. And then we set up a CNAME or an alias record in Route 53 to point to your DNS. And that's it. So you've learned a lot about AWS Certificate Manager in this lecture. I hope you liked it, and I will see you in the next lecture. So we have seen KMS for encryption, but now let's look at Cloud HSM. So with KMS, AWS will manage the software for the encryption and will have control over the encryption keys. But with Cloud HSM, AWS will provision some encryption hardware. It's called an HSM device, so a dedicated hardware, which is a hardware security module. And then we are going to manage our own encryption keys entirely, not AWS. So we have full control over the encryption keys. The HSM device is going to be set up within the cloud of AWS, but it is tamper resistant with FIPS 1042 level 3 compliance, which means that if anyone tries to access your HSM device manually, then they're going to be stopped and blocked. The Cloud HSM device supports both symmetric and asymmetric encryption keys, so that means that you can have, for example, SSL and TLS keys on top of it. There is no free tier, and to use the Cloud HSM device, you need to use the client software, which is quite complicated and out of scope right now. There is an integration between Redshift and Cloud HSM if you wanted to leverage Cloud HSM for your database encryption and key management. Cloud HSM is a really, really good candidate if you want to implement SSEC type of encryption on top of S3, for example, because you are managing your own encryption keys and are storing them into this Cloud HSM. So with the Cloud HSM, AWS will manage your hardware, whereas the service itself can be used on your own. The Cloud HSM client is something you have to use to establish a connection into the Cloud HSM service, and then you are going to manage the keys overall. So the IAM permissions are going to be used to do a create, read, update, a delete of an H&M cluster at a high level, but then you're going to use the Cloud HSM software to manage the keys and manage the users and their permissions to access the keys, which is different from KMS because in KMS, well, everything is managed using IAM. Now, the Cloud HSM clusters can have high availability, and they're spread across multiple AZs, so they're HA, and this is super important to understand, so you can have two AZs, one is going to be replicated from another, and your HSM client can connect to either. So how do we transparently leverage Cloud HSM within the AWS Services encryption? Well, there is an integration between Cloud HSM and KMS. How does that work? Well, in KMS, we're going to define a KMS custom key store, and that will be Cloud HSM, and that means we can get Cloud HSM encryption for EBS, S3, RDS, and so on. So how does that work? Well, we create a Cloud HSM cluster, and we define a KMS custom key store that is going to be connected to our Cloud HSM cluster. From there, if we create an RDS database instance that has an encrypted EBS volume with KMS encryption, well, internally, this KMS encryption is going to be leveraging encryption keys within your Cloud HSM cluster. The benefit of doing this is, number one, we are actually using our Cloud HSM cluster, and number two, any API calls made through KMS that reaches our Cloud HSM cluster is going to be logged in CloudTrail. So if we compare Cloud HSM and KMS, the tenancy of KMS is multi-tenant, whereas for Cloud HSM it's single tenant. They both have the same standard. The master keys are 3 kinds on KMS. They're AWS owned, AWS managed, and customer managed CMK, whereas for Cloud HSM, it's only customer managed CMK because AWS cannot access your HSM device. In terms of key type, it is very similar: symmetric, asymmetric, and digital signing for KMS, and symmetric, asymmetric, and digital signing and hashing for Cloud HSM. In terms of key accessibility, well, KMS is accessible in multiple regions, but because Cloud HSM is deployed in a VPC, you can share it across VPCs using VPC sharing, and so that means that's going to be accessible across multiple regions if you wanted to. For cryptographic acceleration, well, you can set up none on KMS, but with Cloud HSM, you have SSL and TLS acceleration you can use at your load balancer level, or you can use Oracle and TDE acceleration as well for your database, that is Oracle-based. For access and authentication, you have IAM for KMS, whereas Cloud HSM has its own security mechanism to manage users and their permissions and their keys. And then finally, for high availability, well, KMS is a managed service and is always available, and Cloud HSM will have multiple HSM devices over different availability zones. Other capability is CloudTrail and CloudWatch for KMS, whereas we have MFA support as well for Cloud HSM. Finally, KMS is part of the free tier in AWS, whereas Cloud HSM is not. So that's it for Cloud HSM. I hope you liked it, and I will see you in the next lecture. So now let's talk about AWS WAF, the Web Application Firewall. It's used to protect your web application from common web exploits at the layer 7. Just a reminder, layer 7 is HTTP, so it protects you against HTTP exploits, whereas, as comparison, layer 4 is for TCP or UDP protocol. So this WAF, this Web Application Firewall, can be deployed on the application balancer, an API gateway, CloudFront, the AppSync GraphQL API, or Cognito user pools. So remember, this is very important, you remember the targets of WAF, because the exam will try to trick you and, for example, make you deploy WAF on an NLB, but this is not possible. So once you've deployed a firewall on these services, you can define Web ACL, their Web Access Control List, and their rules. And so you can set a rule, for example, to filter based on IP addresses. So you can define an IP set. Each IP set can be up to 10,000 IP addresses. And if you need more IP addresses, you can use multiple rules for more IPs. You can also filter based on HTTP headers, body. You can use URI strings to protect from the most common attacks, such as SQL injection and cross-site scripting. You can have size constraints to make sure that the requests are only up to, for example, 2 megabytes, or geomatch to allow or block specific countries. And you can even have rate-based rules to count the occurrences of requests per IP for DDoS protection, for example, to prevent a specific IP from sending more than 10 requests per second. So these web ACLs, they're regional, except for CloudFront, where they are defined globally. And if you see the term rule group, well, it's a reusable set of rules that you can add to many web ACL. So this is just to organize them. So WAF has a really good use case. So what if you want to get a fixed IP on our application while using WAF with the application load balancer? So WAF does not support the network load balancer because the NLB operates on layer 4 and WAF is for layer 7. So therefore, to provide WAF, you need to have an application load balancer. But we know that an application load balancer does not have fixed IPs. So to solve the problem, we can use a global accelerator to get fixed IP for our application and then enable WAF on our ALB. So the architecture is like this. We have one region with an ALB and EC2 instances. We're going to front our ALB with a global accelerator to get a fixed IP for our application. And we're going to attach a web application firewall with a web ACL on the same region as where our application load balancer is located. And therefore, we have achieved our target architecture. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. So now let's talk about AWS Shield. And Shield is a service to protect yourself from DDoS attacks. So what is DDoS? Well, it's a distributed denial of service. And the idea is that your infrastructure is going to suddenly receive many requests at the same time from a lot of computers all around the world. And so the goal of it is to overwhelm and overload your infrastructure. And this way, your infrastructure cannot serve your real users. And this is what's called a distributed denial of service. So we can protect against it. So we have the AWS Shield standard service. It's a free service. It's already activated for every customer of AWS. And it's going to give you protection from attacks such as the SYN or UDP floods, or any reflection attack or other layer 3 or layer 4 attacks. And if you want to get advanced protection, you can use the AWS Shield Advanced service. So this is an optional DDoS mitigation service. It costs around $3,000 per month per organization. And the idea is that you're going to get protected against more sophisticated DDoS attacks on Amazon EC2, Elastic Load Balancing, Amazon CloudFront, the Global Accelerator, and Route 53. It also gives you access, 24/7 access, to the AWS DDoS response team, So in case you get attacked, you'll have someone to help you and guide you along the way. In case you are incurring higher fees because you are also being attacked, this shield advance protects you from these higher fees. And this shield advance has an automatic application layer DDoS mitigation, and it's going to mean that it's automatically going to create and evaluate and deploy WAF rules to mitigate layer 7 attacks. So automatically your web application firewall will have rules to help you mitigate these attacks, DDoS attacks, if they happen at the layer 7, which is great. Okay, so that's it for this lecture. I hope you liked it, and I will see you in the next lecture. So now let's talk about the AWS Firewall Manager. So this is a service to manage all the firewall rules in all accounts of an AWS organization. So the idea is that you can manage rules across many accounts at the same time. So you can set a security policy, and a security policy is a common set of security rules. And so this could be web application firewall rules, so they apply to the ALB, the API gateways, CloudFront, and so on. Or it could be Shield advanced rules, so for your ALB, CLB, NLB, the Elastic IP, and CloudFront. It could be security policy to standardize security groups for EC2, your application load balancer, and ENI resources in your VPC. And it could be as well rules for your AWS network firewall at the VPC level, so this is something we haven't seen yet, or your Amazon Route 53 resolver DNS firewall. So the idea is that Firewall Manager allows you to manage all your firewall in one place. The policies are created at the region level, okay? And then they're applied to all the accounts of your organization. And on top of it, if somehow in your organization, for example, you create a WAF rule for an application load balancer, and somehow there's a new application load balancer being created, then automatically the Firewall Manager is going to apply the same rule to this newly created ALB. That's a feature of Firewall Manager. So you may ask yourself, what is the difference between WAF and Firewall Manager and Shield? Well, WAF, Shield, and Firewall Manager are used together for comprehensive protection of your accounts. So first, you define your web ACL rules in WAF. And in case you need, one resource at a time protection, then WAF is going to be the right choice for you. But if you want to use WAF across multiple accounts and accelerate WAF configuration and automate the protection of new resources, then you would manage your WAF rules within Firewall Manager, and Firewall Manager will just apply all these rules to all your accounts and all your resources automatically. So now we also have Shield Advanced to help you get protected against DDoS attacks. And it has additional features on top of WAF, such as a dedicated support from the Shield response team, SRT, advanced reporting, and also it can automatically create WAF rules for you. And if you're prone to frequent DDoS attacks, then you should definitely consider purchasing Shield Advanced. And so Firewall Manager can also help you deploy Shield Advanced across all your accounts. So hopefully the distinction is pretty clear for you now. I hope you like this lecture, and I will see you in the next lecture. Okay, so let's have a look at WAF and Shield in this lecture. So here in WAF, we have the ability to protect our web applications from common web exploits. And this is going to protect multiple types of resources, such as CloudFront distributions, API gateways, APIs, application balancers, and so on. So what I'm going to do is that I'm going to just create a protection pack and see what are the steps to do so. So if we look at this, first we need to tell AWS about our app. This is the new flow. So for example, let's say we are pretty much everything. This is going to give us the best options. So then what do we protect? Both the API and web version, or just the API or just the web version? Again, we're just going to choose both as an option. Now you have resources to protect. So it turns out that if you click on info, you will see the kind of resources that you can protect. For example, you have Amazon platform distributions, and it tells you what you're going to do by protecting distributions, amplify applications, Amazon API gateway or AppSync APIs, load balancers, for example, to filter malicious traffic before it reaches your application server, community user pools, and app owner services, and of course, over time, maybe you will have more services. So it turns out because we have none of this already in our accounts, we can't really click on add original resources, it's not going to give us anything, or we cannot also click on add, for example, platform distribution tenants, because I have deleted everything. But if we had, we could add it. But that's fine for this tutorial, we don't need to, so we just click on skip for now. Now we need to select the WebACL resource types. So either it's going to be amplify application, CloudFront distribution, and CloudFront distribution tenant. It's going to be a global rule. Or we have this option to select all the other kind of services. So this is up to us. Let's just select the second one. And next we choose the initial protections. So this is the kind of stuff we can use AWS for, or we can build your own. But if we use, and I'm going to just close this info panel, if we use the recommended rule, we have some rate limits for GET requests, rate limit for post and delete requests, Amazon IP reputation list, anonymous IP protection, managed IP DDoS protection, and bot control protection.